Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 70 in our incredible new tutorial series where you're unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Kepler kit for Raspberry Pi Pico W. Now, hopefully most of you guys already have your gear, but if you don't, look down in the description. There is a link over to Amazon and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to do is I'm going to show you my solution to the homework assignment that I gave you in lesson number 69. But I must start by asking, were you able to do the homework? If you were able to successfully complete it, leave a comment down below. I am legend. Double chest bump. If you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. Well, hopefully most of you guys were able to do it because we've been working on this concept in the last 3 or 4 lessons. And what we're doing is we're learning how to program so that we operate both cores on the Raspberry Pi Pico W. It's a dual core machine, and so we're learning how to write programs where we take advantage of both cores. And we're doing that using threading. Okay, one of the unique challenges that comes up when we're using threading is how to exit a program cleanly, where when we terminate the program, we clean things up and we don't leave that other thread up there running, or we don't let that other thread up there crash. And so we've talked in a couple of lessons about how to cleanly exit your programs. So we're going to practice those things by me showing you my solution to the homework assignment that I gave you in lesson number 69. But a quick review of what that homework assignment was. What you were supposed to do is you were supposed to connect up a servo and a red, mind you, a red button to the Raspberry Pi Pico W. And what the assignment was, it's supposed to sit here, and then if you press the button, the servo is supposed to smoothly move from 0 to 180 degrees. And then if you toggle the switch again, it's supposed to go from 180 back to 0 and kind of go back and forth like that as you toggle the button, and exit the program cleanly when you do a keyboard interrupt or a Control-C. Okay, I hope you guys were able to do this, but let's jump in and let's see if we can put this program together. And so we'll come over to Thani. Well, let's see, I guess I should show you a couple of things here. On this, my servo, the orange wire, which is control, is hooked up to GPIO pin 17. The red wire, which is power, is hooked up to physical pin 40, and the brown wire, which is ground, is connected to physical pin 38. And then as far as the button goes, I have the button connected. I've got one leg of the button connected to GPIO pin 16, and then the other leg of the button is hooked to ground. And then we will be using a pull-up resistor, an internal pull-up resistor on that. Okay. So that's how you get things hooked up. But let's go ahead and see if we can kind of start programming this thing. And I think the first thing I want to do is just get this button working as a toggle switch. And so let's go ahead and do that. So I'm going to need to, from machine, import pin like that. We're always going to need to do some delays, so we're going to import time. We know we're going to be doing threading, so I'm going to import underscore thread like that, underscore thread. And then we also know that we're going to use that servo, so import servo, and I showed you last week, if you don't have the servo library, in last week's lesson I showed you how to install that servo library. So you can go back to lesson number 69 if you need to review that. Then what do we know? We know, let's go ahead and do our, let's call it red but pin like that, and that was pin 16. I said, now let's create our button object, which would be my red button. You can call yours whatever you want. I called mine my red button, and that is pin, the method that we imported from machine. And then what pin do we want to do? Red but pin that we just set up, and it's going to be a pin dot in. Be careful with the capitalization. Capitalization matters in all of this. So we're going to set that red but pin as an input pin, and then also what it is going to be is we're going to activate the pull up resistor like that. Okay. Now we need to keep track of where the button state is this time through the loop and where the button state was last time through the loop. And so if it was down last time and if it's up this time, then we'll want to toggle. So we need to kind of know what the red but state now is. And I'm going to go ahead and just set that to 1, because when it's not been pressed, it's 1. And at the top of the program, no one's pressed it. So it's going to be red but state now is equal to 1. And then what was it last time? Well, this is the first time it's run, so it's going to be 1 as well, meaning it hasn't been switched. State old. So we have red but state now and red but state old, and we're going to set that to 1 as well. Okay. Now let's come in and let's define our main while loop. But we know that we're going to want to exit cleanly. So remember what we do to exit cleanly. We put a try. And then if we have a try, we're going to need an accept. And what are we accepting on? We're accepting on keyboard interrupt, like that. I'm just trying to do the things, the framework that I usually forget. And so I'm just going to do it all right now. So I have a try, I have while keyboard interrupt, and then we'll come in and fill in the details. But what do I want to try? I want to try to do a while true. True, when is true? True is always true. This will run until it crashes. And then if it crashes or gets a keyboard interrupt, it will jump out of this. Okay. So now we're going to say, what is red but state now? We're going to read the state of the button. And how do we do that? We do that with my object is my red button dot value. So now we're reading the state of the button. If it's up, it's going to be a 1. If it's pressed down, it's going to be a 0. So we're going to do that. And then what are we going to say? We're going to put our colon in. Now what are we going to say? We're going to say if red but state now is equal to 0. So this time it's not pressed, and red but state old equal 1. So if last time it was pressed down, a 1, this time it's up, a 0, that means the button was pressed. And what are we going to want to do? We're going to want to toggle. And so that needs to be a colon there. All right, so I'm just going to come down here and I'm going to say print toggle. That'll just help me debug it. So I see that I'm going to see if it sees that button press, and I'll know it sees the button press if it prints out toggle. Okay. Now what I'm also going to do is I'm going to have something called servo toggle. That's the variable. And what does this mean? This means that if last time the button was down and this time it's up, true, I want to toggle the servo. So this is a variable telling me that I need to do what? I need to toggle the servo. So if it's 180, I need to come to 0. If it's 0, I need to go to 180. So it tells me servo toggle equal true. Well, if I'm going to do that here, I probably need to up at the top. I need to up at the top talk about that and say servo toggle equal false. Why false? Because no one's had a chance to press the button yet. So we want to start off with, do I want to toggle? No, because nothing's happened. But it's usually good to define your variables up here at the top so you don't run into any type of unanticipated behavior. Okay, so now, so here I'm setting servo toggle equal to true. I think that's good. And then, yeah, that's just saying that it needs to be toggled. And now what do I need to do? Red but state old is equal to red but state now. And so what that's doing, that's just saying I'm at the bottom of my loop. And so I've got to record what my value was. This time my new value now becomes the old value. And now we probably need to just do a little bit of a time.sleep here, about 0.1, just something to slow this thing down just a little bit. Okay. So let's go ahead and run this and just see what kind of errors, what kind of crazy mistakes we've already made in here. So let's run this thing. Okay. Line 16 right off the bat. Okay. So we have try, we have while true, we have, there's no colon there. Not on just a simple command like that. That was a silly mistake. Hopefully you guys saw that. So let's run it. And now we move to line 17. Now this one I am sure needs a colon at the end of it. So red but state dot value. Oh, I see what's wrong. This is not indented. All my indentation is off by 1. Because somehow I was treating that read like it was something that it was not. Okay, so we toggle if we end up in this if statement, which means we got a button push. So let's go ahead and run this. And now our problem comes down to 23. Okay, I see. We haven't said what to do on a keyboard interrupt, okay? So what we're going to do is we're going to print that we got down here just to help us debug keyboard interrupt so we see that we got there. And then what I'm going to do is I'm just going to do a time.sleep of, let's say, 0.1. And then I'm just going to say print program is done. Now this doesn't really need it if you're just doing what we're showing here, which is just the main core running. We don't need to do this, but we know that we're going to be adding that second core here in a minute. So let's just get this basic program running before we have to make it fancy. Okay, so that looks good. It's running now. If I come over and press the button, okay, if I come over and press the button, it is not seeing the toggle. It is not seeing the toggle, so I'm going to Control-C to get out of the program. Look at that. It saw the interrupt. The program is done. That part's working. But why is it not seeing my button? Why is it not seeing my button? Where is my button hooked up to? Make sure that I am on the right, have this thing on the right pin here. That looks like I am using GPIO pin 16, I do believe. And if I come up here, I have red butt pin is 16. That looks good. That looks good. So why is it not seeing that? Let's take a look. So I said try and accept while true red but state now. Let's just put a print statement in here and see if it's getting that read. So I'm going to say print. One thing I see is this shouldn't be RUD. This should be red like that. There was a typo there. That could have been what was causing the problems. Let's run it. Okay. Toggle, toggle, toggle. Okay, so the push button part of the program is working. Now we've got to take that push button and we've got to make it do something. Specifically, we've got to make it sweep the servo. So we don't want to be sitting and listening for a button push and sitting and waiting to do the servo. So we're going to do that on 2 different cores. Okay, so we're going to operate the servo on the other core. So how do I do that? Well, I'm going to define my other core like that. Okay. And now what am I going to need? Well, I'm going to need global. I need to know what servo toggle is. Okay. Where do I define servo toggle? I define that down here. I set it to true if I need to toggle. So I need to know what it is. So what do? I make it a global variable. Now this thread on this separate core will always know what that main variable servo toggle is. Now the other thing that I'm going to need is I'm going to need this global variable of running, right? And that lets me keep track of, should I keep running true or should I stop running, which would make running false. So is running true or false? Should I keep running or not keep running? So I need to make that global. And if I'm going to do that, then I need to come up here and I need to set my running equal true, just so it starts with some sort of value. Okay, now what do I need to know? I need to kind of keep track of where my servo is. So I'm going to keep track of servo state, like what state is my servo in or what angle is my servo at. So we got to start it somewhere. So I'll say servo state is equal to 0, and that would be 0 degrees. Okay, now while what? Running. Okay, normally inside of this thread you would say while true. But I want to say while running, because then later outside the program, if I make running not true, then that will what? That will kill this thread. And in fact, we would do that down here, right? We would say in the accepts, you hit Control-C, you end up down here, you print that you have a keyboard interrupt, and then after you print that you have a keyboard interrupt, then what do? You say running is equal to false, and then what will that do? That will come up here, and that will make running false, and then it will drop out of this while loop, and the thread will stop. Executing. I hope that makes sense. I really hope that makes sense. So now what do we want to do in this while loop? What do we want to do in this while loop? Well, if I get a toggle and I'm at 0 degrees, I want to sweep to 180 degrees. If I get a toggle and I'm at 180 degrees, I want to sweep to 0 degrees. And so let's think about that. While running, well, if I'm at 0 degrees, I would say if servo state equals 0 and servo toggle equal true. So what two things have to be true? I'm at 0 degrees and the button's been pushed asking me to move. Well, in that case, what do? I move. And how do I do that? For I in range, we're at 0, so we'll start at 0. We'll go to 180 and we'll go in steps of 1 like that. And then what do I want to do? Well, I'm going to have to set up my servo if I'm going to move it. So I'm going to come up here. I set servo toggle. I set running to true. What am I going to have to do? I'm going to have to say servo pin is going to be equal to, did I say that was pin 17? Yeah, pin 17. Now I've got to create my servo object. So I'll just say my servo, you can call yours whatever you want, is servo, uppercase the library dot servo, lowercase the method of servo pin. Okay, so now I've created my servo, I've given it a pin number, and I can come down here, and what can I do down here? I can move the servo. So I'm going to go from 0 to 180. I'll say my servo dot position of I, like that. And then I'm going to do a little bit of sleep, time dot sleep of let's say 0.05, like that, okay? So if the button's been pressed and released and I'm at 0 degrees, I want to sweep from 0 to 180. Well, what is the other case? If servo state equal 180 and servo toggle equal true, then what do I want to do? Well, I want to go the other way. For I in range from 180 to 0 in steps of -1, like that. And then what do I want to do? My servo dot position of I, and then a time dot sleep of 0.05. Okay, now what is the problem? The problem is right here. What is going to set servo true? Okay, when I press the button, servo toggle is going to be set to true. And because servo toggle is set to true down below, and because I'm at 0 degrees, I'm going to go from 0 to 180. But what's wrong? The next time through this while running loop, servo toggle is still true. And so what's it going to do? It's going to keep doing this. It's going to keep doing this. So once I've done it, I have done the servo toggle request. So I need to what? I need to now say servo toggle is equal to false. Why? Because you wanted a toggle. I gave you a toggle. Now I don't need to toggle again until you press the button again. So I say the servo toggle is equal to false. Also, what is my servo state? Well, here, my servo state was 0, and then I moved it to 180. I better down here remember that servo state is now 180, like that. Now, same thing here. After I go through that for loop, I have completed moving the servo, so I don't need to move it. So I'll say servo toggle is equal to false, and then what? Servo state. Well, this time I was at 180, and I went from 180 to 0. So when I drop out of this, what is my servo state going to be? It was left in 0. So next time through the loop, everybody knows where they are. That looks pretty good. Now, what else do I need to do? Now, after I fall out, so when running becomes false, I'm going to drop out of this while loop, and I'll drop all the way down to here, and I just want to print other core terminated. All right, so if this prints, I'm going to know that I dropped out of that while loop in the thread. I'm at the end of the thread, and the thread has ended. So this will just let me see, in fact, like if the program stops and it doesn't print other core terminated, then I know either it's still running or it crashed in an ugly way. That for me to know that I cleanly exited, I need to see this thing print out on my terminal. Okay, so now if we're going to do this down here, after we define the thread, we need to start it. So I'm going to say underscore thread dot start new thread, start new thread of what? Other core, and then like that. And I think I used an uppercase C as the convention I've been using. I don't pass it any parameters. I close that. And then we always like to give it a little time to get started before we jump down into the other core. So I just give it like that. Okay, let's see what happens when we run this. Probably full of errors. Okay, let's see what happens. It toggled, and look, boom. Do you see how I'm going smoothly from 0 to 180? Okay, very, very good. And it stops. And now if I toggle again from 180 to 0, look at that. Okay, but now what is the real question? The real question is, can I exit cleanly, right? Can I exit cleanly? And so I'm going to do a Control-C, a keyboard interrupt. And what happens? It jumps down to keyboard interrupt. It sets running to false. And then when running is false up here, when running is false, it drops out of the while loop. It prints other core terminated. Okay. And so that happens as soon as I make running false. And then after the other core is terminated, then what does it do? It prints that the program is done. So a super clean exit, a super clean exit. So we'll run it again. I press the button, have a sip of coffee. That looks pretty good. That looks pretty good. Okay, gets over here. And now I'm going to Control C and I get a clean kill. I get a clean exit, okay, of this program. And that is really, really good. Okay, guys, let's talk about your homework for next week. Let's talk about your homework for next week. I'm going to run this thing. What if I toggle it? And then what if I toggle it and while it is running, I give it a Control C? Okay, I'm going to give it a Control C while it is moving. Boom. What did I do? I just broke the program. Now, what was different? Earlier on, I would always do Control C after the servo had finished moving to its new position. What did I do this time? As the servo was still in motion, I killed it. And if I killed it then, what happened? It died ugly. So I saw the toggle, that's good. And then I got the keyboard interrupt, that's good. So I got the keyboard interrupt, that's good. But then what did it do? The main thread, my main program, my primary core main program terminated because I got here, it terminated. And what did we never see happen? We never saw this core stop. So either it's still running or it crashed early. I mean, it crashed. It crashed ugly. So either it's still running or it crashed ugly. But if I come up and try to run the program, I just get an error, and I would have to unplug this and plug this back in. So what your homework assignment is to take this dandy program that hopefully you did by yourself, and if you didn't, at least you saw how I did it, and go in and make it exit cleanly, get a clean exit with no errors, no ugly red marks. Even if you do the Control C or the program exit as the servo is moving. Okay, even if you do it as the servo is moving, I want it to end cleanly. Okay, guys, I hope you all are having as much fun taking this class as I am making it. Really love the stuff that we're getting into. Also, as always, I want to give a shout out to you guys who are standing with me on Patreon. Your support and your encouragement is what keeps me in the game here. Really appreciate it. You can also help me by giving me a thumbs up on the video and leaving a comment down below. Also, if you haven't already subscribed to the channel, when you do, make sure you ring that bell so that you'll get notification when future lessons drop. And as always, share this video with other people because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.